So welcome. This is 5 day questions for A level mechanics 1. Question for day 3. So in day 1 and 2 we had done question number 1 to 10. Now day 3 question number 11. Two particles P and Q are projected vertically upwards from horizontal ground at the same instant. The speed of projection of P and Q are 12 and 7 meters per second respectively. Now what is being told about the ground and the heights P and Q above the grounds are hp and hq respectively. Each particle comes to rest on returning to the ground. Find the set of values of t for which the particles are traveling in the opposite directions. So p, this is point particle p, and this is particle q. So vertically from horizontal ground at the same time. So this is being projected at 1.2 meters per second, and this is projected at 12 meters, 7 meters per second, and this is projected as 12 meters per second. 12 meters per second and 7 meters per second. Now we will be finding it out the time of ascent, time to take go up, and it would have went up over here. So the time of ascent for particle P, time of ascent is going to be u upon g, which is nothing but what, 12 divided by 10, which is 1.2 seconds. Whereas for Q, time of ascent is going to be 7 divided by 10, u by g, which is 0.7 seconds. So the set of times for which the particle are traveling in the opposite direction. So after 0.7 seconds, q will start coming downwards, but t will be continue to go upwards. So from 0.7 to 1.2 seconds, p is going upwards, whereas q is coming downwards. So they are in the opposite directions. At a certain instant P and Q above the ground is 3hp equals to 8hq. Find the velocities of P and Q. So E has given, so for P and for Q. For P, what is that? With what velocity are we doing it at? We are throwing with the velocity of 12. So ut minus half g t square, t1 t square. And for Q it will be nothing but what again? Ut, which is 70 minus half g t square. Now, but he has been told that what has been told? It has been told that 3hp equals to 8hq. 3hp equals to 8hq. So this is hp and this is hq. So what is that? It becomes now 3 times of 12t minus 5t square should be equals to 8 times of 70 minus 5t square. So I have done it out, ut minus half gt square. So this becomes 36t minus 15t square equals to 56t minus 40t square. Then what am I going to get from there? 25t square equals to 25t square equals to 26t. Then t and t gets cancelled, so I'll be getting it out, which is, let me add a page over here to do more calculations. That will be the better way. So minus 15t square plus 40t square equals to 56t minus 36t. So which is 25t square equals to 20t. So 25t equals to 20. So t equals to 20 divided by 25. 20 divided by 25, which is going to be nothing but what? 0.8. 0.8 seconds. So now for P, V equals to U plus AT. U was 12 plus A was minus 10 going upwards, and time is 0.8. So which is going to be 4 meters per second. For Q, V equals to again U plus AT. U is nothing but what? 8. Then it was thrown with a 7. U was 7. A is minus 10, and T is nothing but 0.8. So nothing but how much does it becomes? Minus 1 meters per second, means it is coming downwards. That's going to be the answer. Now coming to the next question. Next question, it says a walker travels along a straight road passing through the points A and B on the road with speeds 0.9 meters per second and 1.3 meters per second. So this is A, this is B. At over here, the speed was 0.9 meters per second. At over here, the speed was 1.3 meters per second. The Walker acceleration between A and B is constant and is equal to 0.004 meter per second square. Find the time taken by the Walker to travel from A to B. So, initial velocity we know, final velocity we know. We have to calculate the what is this time. So initial velocity is 0.9, final velocity is 1.3, and acceleration is 0.004. So time. So I'm going to use V equals to U plus AT. 1.3 equals to 0.9 plus 0.004 t, which gives me t value as 100 seconds. That's going to be the answer. A cyclist leaves A in the same direct at the same instant as the walker. She starts from rest. She's starting from rest. She's starting from rest and travels in a straight road and passing through B at the same instant. She'll take the same time, and at t seconds after leaving A, the velocity is kt cubed. Show that t equals to 64.5. The speed of the walker and the speed of the cyclist are the same. Correct to three significant figures. Now for the cyclist. She is starting from rest. So initial velocity is going to be 0. And velocity is nothing but what in the form of kt cube. So if at all I want to find the distance, distance is equals to kt cube integration dt. So distance equals to kt to the power of 4 upon 4 plus c. But we know that when t equals to 0, s equals to 0, this gives me c equals to 0. So the distance is nothing but what k t to the power of 4 upon 4. Now distance that it takes the same 100 seconds. They say that she takes the same 100 seconds. So what am I going to get it out? And same distance. Distance is also going to be the same. And have we calculated the distance earlier? We haven't calculated the distance. So we need to calculate the distance also. In part 1, we need to calculate the distance. So let's calculate the distance over here. So v square equals to u square plus 2as. So 1.3 square equals to 0.9 square plus 2 times 0.004 times s. So this gives me s as 1.3 square minus 0.9 square divided by 2 times of 0.004. This is going to give me 110 meters. So this is going to travel the same distance. So 110 equals to k times 100 to the power of 4 divided by 4. As such, this gives me the value of k as how much? 4.4 times 10 to the power of negative 6. That's going to be the time, the value of k. So again, I add a page over there and I do calculations over here. 110 equals to k times 100 to the power of 4 divided by 4. This gives me the value of k as 4.4 times 10 to the power of negative 6. But what is he asking us to find it out? Show that the time t equals to time t equals to The speed of the walker and the speed of the cyclist are the same. Correct to three significant figures. The speed of the cyclist and speed of the walker should be the same at t equals to 64.05 seconds. So now velocity of the walker equals to nothing but what? V equals to u plus at. U is nothing but what? 0.9 plus a is 0.004 times how much? 64.05. That's going to be nothing but how much? 1.16. This is the velocity of the walker. And velocity of the cyclist, we will be finding the velocity of the cyclist. Velocity of the cyclist also I'm going to do it at v equals to u plus at. U is nothing but what? Or we cannot use v equals to u plus at. We are going to use the formula at cube. K was 4.4 times 10 to the power of negative 6 cube. 64.05 whole to the power of 3. This also gives me nothing but 1.16 meters per second. So both the velocities are going to be the same. Correct to three significant figures. Find the cyclist acceleration at the instant when she passes through V. So we know that velocity equals to kt cube. So acceleration equals to the derivative of that one, which will become 3 kt square. So and at the instant when she passes through B, so the time is going to be 100 seconds. So 3 times 4.4 times 10 to the power of negative 6 times 100, which is going to be nothing but how much? 3 times 4.4 times 10 to the power of negative 6 times 100 whole square, which is going to be, when I do by calculator, 0.132 meters per second square. That's going to be the answer. So whenever you have velocity, you need to find the derivative to find the acceleration. That's going to be the answer. Now coming to question number 13. This is again a question based upon velocity time graph. The diagram shows the velocity time graph for the motion of two particles P and Q which travel in the same direction along the straight line. P and Q both start at the same point x on the line, but Q starts to move t seconds later. It will be starting to move t seconds later to P. Each particle moves with a speed of 2.5 for first 20 seconds. The speed of each particle changes instantaneously to 4 meters per second after it has been moving for 20 seconds, and they continue at this speed. Make a rough copy of the diagram and shade the region whose area represents the displacement of P from X at the instant the Q starts. So Q is starting at over here at the time t seconds. It is starting over there. Now what is happening to P? It will travel from 0 to 2.5 at for 2.5 seconds over here for 20 seconds. So this is one part, and after that it travels with 4 meters per second for the remaining time. So this is the total region which it has been P has been traveled before Q starts. It is given that P has traveled 70 meters at the instant Q starts. Find the value of T. So that pink color region plus the red color region is going to be nothing but how much? 70. So the pink color region area is going to be 20 times 2.5 plus the red color region. Red color region is nothing but what? 20 minus t minus 20. T minus 20 times 4. The height is going to be 4. Should be equals to nothing but how much? 70. So this is 50 plus 40 minus 80 equals to 70. 40 minus 30 equals to 70. 40 equals to 100. T equals to 25. The distance between P and Q. Find the distance between P and Q when Q speed is 4 meters per second. So what is the distance? Now coming to part 3. Find the distance between P and Q when Q reaches 4 meters per second. So we came to know that part 3. So first of all, P has a head start of how much distance? 70 meters. Now then the Q will start. Q is starting. So when Q starts, Q will be moving with a speed of 2.5 meters per second for 20 seconds. So the distance traveled by that one will be 2.5 plus 20, which is nothing but what, 50 meters. Q would have traveled 50 meters. But in this same 20 seconds, P would have traveled. P also travels. P also travels, but with a speed of 4 meters per second. So 4 times 20, which is nothing but what, 80. So total distance of P, total distance traveled by P will be Total distance traveled by P will be 70 plus 80, which is 150. And distance traveled by Q. Distance traveled by Q will be nothing but what? 50 meters. So what will be the total difference in the distance? Distance between them. Distance between them. Between them will be 150 minus 50, which is 100 meters. That cliff is 40 meters above the level of the sea. So this was a sea. So this distance is going to be 40 meters above the level of the sea. A man in a boat. There is a boat over here. A man in a boat, what does he do? At the bottom of the cliff is in difficulty and fires a distress signal vertically upwards from the sea level. The speed of the projection, find the speed of the projection of the signal if it reaches 5 meters above the top of the cliff. So he is projecting it out over from here with certain speed, but it reaches 5 meters above the cliff. So what is the speed? So over here, final velocity is going to be 0. And now the total height is going to be nothing but how much? 45 meters. So we know that it's a maximum height question. So the maximum height is going to be nothing but what? 45 meters. So which is u square upon 2g is 45. U square upon 2 times 10 equals to 45. So which gives me u value is going to be nothing but how much? If I try to find it out, which is 30 meters per second. Next, what is he asking? Find the length of the time for which the signal is above the top of the level of this thing. So over here, what is going to be the time for this particular part? So what am I going to do that? I am going to find it out. At what time it is at 40 meters. So S is equals to ut plus half at square. So 40 equals to ut u30t minus half g t square, which gives me a quadratic equation 5t square minus 30t plus 40 equals to 0. So this gives me t square minus 60 plus 8 equals to 0. So t minus 2 times t minus 4 equals to 0. So t equals to 2 seconds, t equals to 4 seconds. So the delta t, the difference in the time will be 4 minus 2, 2 seconds it will be the height. Now coming to part 3. I am coming to part 3. What is that? The man fires another distress signal vertically upwards from the sea level. The signal above the level is for 17 root of square root of 17 seconds. So this time, this is the cliff height and this is the sea level. This height is going to be nothing but what, 40 meters. Now it is above this one for square root of 17 seconds. Now, what is he asking? What is going to be this height is going to ask it out. What is the speed of the projection? With what velocity it has been projected? So, first of all, I have to calculate the maximum height above the top of the cliff. I have to calculate maximum height above the top of the cliff. So, we know that it took square root of 17 by 2 for going up, square root of 17 by 2 seconds for coming down. from here to here. From here to here, the square root of 17 by 2. So what will be the maximum height? Maximum height is going to be half gt square. Half times g times t square, square root of 17 by 2 whole square. We'll assume it as u as what is this, the time taken, because u is 0 over here and it is falling at a certain height. For that particular moment, for this one, I'm trying it as u equals to 0 and distance equals to question mark, acceleration equals to plus g, and time equals to square root of 17 by 2. So what is that height is going to be? 21.25. So total height it has to travel is nothing but what? 21.25 plus 40. 21.25 plus 40. That's going to be the total height. Total distance is 21.25 plus 40, and total time we don't know, and acceleration while coming down is or going up is nothing but what? Minus g, and initial velocity also we don't know, but final velocity is going to be 0. So you use v square equals to u square plus 2as. So 0 square equals to u square minus 2 times 10 times 61.25. This gives me the value of u as 35 meters per second. Vertically upwards with a speed of 17 meters per second. So speed of 17 meters per second. So what is that? It's time of flight. And q. Q is projected vertically upwards with a speed of 7 meters per second. 7 meters per second, t seconds later. Given that the particles reach the ground at the same instant. So what am I going to do? I'm going to find the time of flight. Time of flight. Time of flight. So which is nothing but what? 2u by g. 2 times 117 by 10, which is nothing but what? 3.4 seconds. Now time of flight for time of flight. Time of flight for this one is going to be again 2u by g, which is nothing but what? 2 times 7 divided by 10, which is 1.4 seconds. But both are reaching at the same time. So obviously, what is this? The time difference is going to be 3.4 minus 1.4, which is going to be 2 seconds. So Q has been thrown 2 seconds after P has been thrown. At a certain instant, when P and Q are in motion, P is 5 meters above the height Q. Find the magnitude and the direction of the velocity of the each particle at this one. So, what is that? For P, S equals to ut plus half at square. So, S equals to nothing but what? 17 times t plus 2, because 2 seconds earlier it has been traveling it out, minus half, g is 10, and t plus 2 whole square. Whereas for Q, S equals to again ut plus half at square, which is nothing but what? 70 plus 70 minus half, g is 10, and t square. So, the difference between them is going to be nothing but what? 5 meters. So, 17 times t plus 2 minus 5 times t plus 2 whole square minus 70 minus 5t square should be equals to nothing but how much? 5. Now I am going to expand this one, so it will become 17t plus 34 minus 5t square minus 20t minus 20 minus 70 plus 5t square equals to 5. So 5t square gets cancels. So now what does it becomes? 10t minus 10t, 14. 14, 14 and 5, 9. 9 minus 10t equals to 0. So t equals to 0.9 seconds. So what's going to be the time? Time equals to 0.9 seconds. That's going to be the answer. So that completes this video. See you in the next video. Bye.